Okay, in this PHP security tutorial I'm going to briefly talk about SQL injection. I've just quickly set up a sort of check password page here. Obviously this isn't the best way to set up a login system, but I just did it quickly for the sort of purposes of this tutorial. Just close that file. Basically what this page does is it connects to the database, it checks if the form has been submitted. If it has, it does a query to get the number of rows where the username and password combination supplied is in the table, and then it gets that number, and then a bit further down in the HTML section, if that number has been set, i.e. if the form has been submitted, if the query has been performed, it checks if this number is 0, and then it tells you you've entered an incorrect password. And if the number is not 0, it tells you access granted. It doesn't actually do any login type stuff, it just tells you that the password is correct. The database we're using is this one that I've got open here, just called it user system. I'll be using this in another tutorial that's coming up, so just sort of using the same database. What we store in this table is the user ID, just standard primary key auto incrementing, the user name, and the user password, which is a SHA1 hash of whatever they enter. Okay, so firstly let's demonstrate SQL injection. Let's just demonstrate the actual system. Just loading the page, we get a blank page with the form on it. If I try and log in with like the admin user, and I can't remember what I set the password to, but if I leave the password blank and hit enter, you see we get the fact that the password is incorrect. But if I were to log in with the user admin, or 1 equals 1, like so, hit enter, you see we get access granted without actually having to supply the password for the admin user. The reason this works is because when you try to log in, PHP basically takes the value that you enter into this form, like here we've got admin, and places it in this part of the query. So we had admin there, and I didn't enter a password. So MySQL does this query, which if I just run this sort of raw query in MySQL, in PHP even, you see we get 0 rows because the password combination was incorrect. But with this sort of special input, if you like, let's just see. If you use that, see that was the user variable, which comes directly from the post variable. So the user is able to set the value of this, and if they set it to that string that I entered a moment ago, and entered no password, the query becomes this. So we're counting the number of rows where the username is admin, or where 1 is equal to 1, which is always going to be true. So if I run this query now, like so, you see we get 1, because, well, that's just how it works. So yeah, we're able to get a value from the database, which is not exactly incorrect, because this is the query, it's not returning a wrong value for this. It is just it's basically you're able to get access to the system without having the username and password. So yes, the way we prevent against this is by using a PHP function that escapes these single quotes. For example, you can do it yourself by placing backslashes before them. So if I now run this with this same query, SQL, you see we get 0 rows, because these, when you escape them, it removes their meaning as a MySQL syntax. So I just put those back to variables. Okay, so the way we protect against SQL injection is as follows. For a string, like the username or the password, we use the MySQL real escape string function. Basically what that function does is it escapes all characters in that input that have meaning in MySQL. If you go on the php.net site page for it, there is a list of characters that it will escape. Single quotes is one of them, double quotes as well, new lines, line breaks, null bytes, I believe, a few things. Anyway, so now, well, let's just try it out. Just quickly say, you don't need to escape the password, like in this case, because it's converted to an SHA1 hash, which is always just a string of numbers and letters. So whatever they enter in the password box will be converted to this hash, which can never have a character in it that has meaning in MySQL. The same goes for MD5 and some others. So yeah, that's why we're not applying this function to the password in this case. So yeah, so that's save that file. Go back to our web page. If I just click login again, you see we get incorrect password. The query hasn't been well, it has been executed, but it has returned 0, meaning that the access granted message has not been shown. So yeah, that is SQL injection and how to prevent it causing issues for your site for strings. For numbers, like say we had the same query, but it was based on the user ID, and we were supplying the user ID here, so I'll just create this new variable user ID, and we weren't talking about the password at all for some reason. Oh no, yeah, let's leave the password. Obviously for an integer you wouldn't quote the value, so the Mr. Bad attacker person could still perform SQL injection even if you had applied MySQL real escape string to this user ID variable. Like for example, if they gave the user ID as it's like 7 or 1 equals 1, none of those characters would be escaped by MySQL real escape string. But say if you pasted this query, this section, this value here, you can still see that it still has the same meaning. It's checking where the user ID is 7 or 1 equals 1, which is always true. So that's why that is still a problem, because these characters would still be allowed through, if you like. The way we protect ourselves against SQL injection from integer values like this is to use PHP's typecasting to convert this to an integer, to make sure it's only integer. Like say if you had the string integer values, I should have said, sorry, a string like so, user ID equals this, and you cast that to an integer by doing, well, okay, let's simulate that it comes from a form like so, and then say if you were to set user ID equal to post user ID, this would be open to SQL injection as I've just explained. But if you were to use typecasting, that's how you do that. This is the type in brackets before the whatever it is you're doing it to. So in this case we're typecasting to an integer. If you were then to output this variable, all you would see is 7, because PHP will drop any non-numeric character, anything that follows the first non-numeric character, which in this case is a space. So I can demonstrate that just by doing echo user ID like so, and it should be now that if I just submit the form, you see we just get 7. We don't get this full output. If I remove this and do the same thing again, you see we get 7 or 1 equals 1. So that's how we protect ourselves from SQL injection in integer columns. And that covers pretty much everything that I wanted to talk about in this video. So yeah, that's pretty much it. Okay, so thanks for watching, and hopefully you'll be able to write some securer code. Oh no, there is one more thing I should mention, sorry. Magic quotes. Basically, when PHP was like version 4, they introduced this thing called magic quotes. Basically what that did is it automatically applies the add slashes function, which is sort of similar to MySQL real escape string, but with one difference, is that add slashes was written by the PHP developer people to be generic, so that it would work with all database extensions, because you can obviously use PHP with MS SQL and a few others, actually loads of others. Okay, so it doesn't. There are still some cases where it will leave characters unescaped, and obviously it doesn't protect against integer. It doesn't protect integer columns, as I just mentioned. So what you need to do is basically you need to say, if you have magic quotes on, your value of post user would be add slashes post user. So if you have magic quotes on, you need to use the strip slashes function, like so. You wouldn't add slashes yourself. PHP does this sort of hidden to you, so the only code you would use is that, and then you need to apply MySQL real escape string function to this full result. Obviously this is only if you can't turn magic quotes off. If you are able, you should definitely disable it, because it's ridiculous, frankly. It causes so many problems, and yeah, it makes you have to call strip slashes all over the place. One way around it would be to define a function, which also is quite a nice thing to do, because you can shorten the MySQL real escape string function. That function could be something like this: input, and then we're going to use the get magic quotes GPC function, which just returns 1 or 0 if magic quotes is on or not. So we just do if get magic quotes GPC input equals strip slashes input, oh dear, slashes, strip slashes, yeah, like that, and then we just return MySQL real escape dear, string, no, right, string. Sorry for my typing. Again, input. So that then you can use that function in place of the MySQL real escape string function, which has the sort of, in a way, the largest advantage of being a lot shorter, and also it will be sort of cross-platform magic, and also be cross-platform compatible. Well, we can test this out. I can change this back to user, put the quotes back around it, go back to our page, just hit reload, resend the data, call to undefined function. I've spelled MySQL wrong. No, I spelled real wrong. Very good. String, good. Okay, if I reload the page again, you see we get incorrect password. If I do the SQL injection we tried before, I still get incorrect password. So by defining this function, I mean, you can define this in one of your sort of back-end files somewhere, so you don't have to keep typing this full thing out. And also, say if you copy your script, or you load your script to a new server, or you're writing a script that you want to give out to other people, they might have magic quotes turned on and not know about how to turn it off or why they should turn it off. So it's sort of not really a nice thing to do, because you don't want to be doing all these unnecessary checks, but it's sort of something you have to do if you want to write code that will be absolutely secure everywhere. Oh, one thing I also should say is that double escaping opens up SQL injection. So say if you haven't done this check and you apply MySQL real escape string to a string that already has been escaped by magic quotes, add slashes, you get double escaping. So like, say if someone entered, well, say if they just had a quote, say if the string that they entered was Bob, say if the string they entered was Bob, or 1 equals 1, you would get double escaping, like so, I think. Oh no, maybe it'd be 4. But anyway, it can open up SQL injection possibilities, so that is something you need to be very careful of. Okay, so I'm running out of time. I still promise I'll make a short video at some point. So thanks for watching, and hopefully this will help you write more secure code, SQL queries. Okay, thanks.